Propensity scores, another common estimation procedure. It's very similar to estimating dummy variables. Here are some rough sketches. With dummy variables for two groups, we'd have these two parallel lines. The dummy only shifts the y-intercept. We can imagine if we had those sort of fuzzy blue and red things showing the cloud of observations, those data points are pretty close to each other. It's relatively straightforward to estimate the vertical shift. But what if we have a point way out away from the other x values, that point in the diagram? In this case, the model's basically shifting that red point along the estimated regression line and then measuring the vertical distance between the model position of that point and the other group. That means we have a leverage issue. A slight variation in how well I estimate the regression slope can really throw off the estimation of the vertical distance. So a propensity score model is trying to give more weight to values that are close. Sounds simple, right? Not quite. As you remember from when we discussed KNN estimators, we talked about how the idea of close gets actually really difficult in high dimensions. Our intuition that we take from our three-dimensional world just falls to pieces. So to use a propensity score, we want to use closer values, but defining close can be sort of an art. With that warning, let me give a couple examples. These should look familiar. There's a matching package in R. We estimate a preliminary model trying to consider the impact of being female on wages. The labels might seem odd since we don't necessarily think causation works that way. Being female is not really explained by age or education. But that's just a first stage for the estimation. We're trying to figure out closeness. Then feed that in the matching procedure and let the computer rip. This is a similar estimation looking at the value of education, in this case BA. In these cases, a propensity score estimation isn't too far from the OLS estimators because the data are reasonably dense, so there are plenty of observations that are close. There may be other cases where it gives different results.